Hi everyone, welcome to you all. So today in this video I am going to discuss about branch coverage testing technique. So in my previous videos I have discussed about one white box testing technique, that is the statement coverage technique. So today in this video I am going to discuss about the branch coverage testing technique. So let's discuss the topic. First we have to know that what is branch coverage testing. So as I have already told you that it is a type of white box testing technique. Also in this technique or in this testing is used to test every possible branch in the control flow graph of a program. Now how we can test the every possible branch in the control flow graph? So I will see you everything. I want to discuss with you everything step by step with some super data flow structure. So don't worry about that, just follow me. Okay, so basically in the branch coverage technique, so this is used to test every possible branch in the control flow graph of a program. And in branch testing, each branches in the code is executed at least once. So these are two criteria that we have to fulfill on that branch coverage testing. And one of the simple example, I will cover both these two criteria. Okay, so this is the branch coverage testing. So what is branch coverage testing? So this testing is used to test every possible branch in the control flow graph of a program. And second one is that in this testing, every branch in the code is executed at least once. And obviously the branch coverage testing is a white box testing technique. Okay, so now why do we need branch coverage testing? There are a lot of testing techniques out there, but why we need branch coverage testing? Because it ensures that no branch in the code leads to a abnormal behavior. Okay, and also it guarantees that all branches in the code are reached. Now how? I will discuss you with one example. Okay, now there is one super formula is there for calculate the branch coverage testing. So what is the formula? The formula says that branch coverage equals to number of branch covered divided by total number of branches multiply 100. So this is the formula that we have to remember. Branch coverage is equal to number of branches covered divided by total number of branches multiply 100. Okay, so look one scenario, one code, because everything is depend upon the programming. So the branch, the here we can see the control flow, the graph of a program. So everything is depend upon some coding. Because why coding? Because white box testing, we have to check the in the white box testing, we have to check the internal code structure, internal implementation. So let's think about that. It's some internal code. So my code, my scenario says that int a equals to 5, int b equals to 2. If a greater than b, then print a is the greater. Okay, or else if a not equals to, or if a less equals to b, then b is the greater. Right? So this is the simple programming. This is one simple programming. Now, so this is the programming where int a equals to 5, int b equals to 2, and if a greater than b, then print a is the greater value, or else b is the greater value. Okay, now in my definition, in the branch coverage testing definition, I told you guys that this testing is used to test every possible branch in the control flow graph of a program, and every branch in the code is executed at least once. Now see this diagram. So this is the code, and respect with that code, this is the programming. So respect with that programming, this is the control flow. So here we have designed that flow, that we are starting from here and there, a equals to 5, then b equals to 2, and this is the condition. So it is the condition. So here if a greater than b, this is the condition. If A greater than B. If A greater than B equals to yes, okay, so then print A is the greater value. So here A value is 5, B value is 2. So A greater than B, yes. If yes, then print A greater than A is the greater value, then the loop will be end. That means the program is closed. Or if A greater than B, the condition is that if A greater than B. Okay. So if no, suppose let's just think about that A is the 2 or B is the 5. Just swap the two value. If A is the 2, B is the 5, then A greater than B means 2 greater than 5. No. If no, then B is the greater value. So this is the simple example. Okay, this is the simple example. So this is the control flow structure. So in my definition says that every branch in the code is executed at least once. That means this branch should be executed at least once. If either print A is the greater value or B is the greater value, but should reach at least one value. Okay. Now, so this is the simple program and this is the diagram. This is the control flow structure. Okay, this is the structure. So now we are clear about the structure. So we have given some name like start equals to start here 1 and here A, here this is the 2, here it is the B, this is the 3, this is the C. Like that we have naming some here. Okay. Now just follow that. So this is the simple scenario. Okay, so this is the simple scenario. Now we are going to calculate the branch coverage testing. Just follow me just listen to each and every word very carefully. So now here, how many branches are there? So the branches in the control flow graph, so the branches in the control flow graph are A, B, C, D, E, F, G. So these are the branches of the control flow graph. Okay. So what are the branches are there? The branches are A, B, C, D, E, F, G, E, F, G. Okay. So total 7 branches are there. Okay. So this is one branch A, B, C. This is the D branch. This is the E. This is the F and this is the G. Now I am going to calculate. Before calculate, we have to make some knowledge clear on that. So now I am just seeing you something like branch coverage. Okay. So branch coverage. Branch coverage. Okay. So for maximum branch coverage, we have to take some path. Now how to take the path? Here we can see that here we are starting point is here, then go to this, then go to this, then go to this. Now from this is the condition. From that point, this is divided by 2 parts. So this is one hand, this is another hand. So now, and here this is the end. So we can, so just like that, so we can traverse from with that route, or we can traverse from like that route. Okay. So these are the 2 paths. That is the start. Listen carefully. This is the starting point and this is the ending point. Now your aim is that how to, cover that end point. So now we are starting from here. Go. Now here, this is the condition. Now here we are dividing like, so the path should be like this way. So from this way we can end that loop, or this way we can end the loop. So now the path is like that. So now here we can see that two paths are there. This is the one path and this is the one path. So path 1. What is the path 1? So what should be the path 1 value? The path 1 value is 1A. This is the starting 1A. This is the branch coverage, right? So this is the branch. So that is 1A. So the path is 1A. Then like that, we are giving some, hyphen here. 1A. Then 2B. So 2B. Then 3C. Right? 3C. Okay. Then after 3C, then what should be the next? So this is the 4. Right? This is the 4. So this is the one path. Now first I am taking this path. Okay. So I will go with this path. First I will go with this path. Now this is the 4. Then after 3C it will be 4D. Right? Then what should be? It should be 5F. This is 5 and this is F. So this is 5F. Then what is the last? The last is only 7. 7 is the ending. Okay. So that is only 7. So this is one path. Clear? I am repeating once again this one. So how to calculate the path here? So now we can see that from starting to end. So there is two paths. Either we can go with this path to complete that point, or we can go with this path to complete the end point. Right? First I am taking this path to complete the end point. So now what should be the path? The path is 1A, then 2B. We are just naming that. So starting value I am taking as 1 and the branches is A. For A equals to 5 value I am taking as 2 and the branch is B. For B equals to 2 I am taking as 3 and the branch is C. Then the condition I am taking as 4. So 4, if yes, then this one, this branch I am taking as name as D. And if no, then I am taking the name as E. Then if A greater than B, if yes, that means print A is the greater. Then this point I am taking the name as 5. And this branch I am taking the name as F. And end is 7. Same for here also. So I am taking it as 6 and the branch naming is G. Okay. So what should be the path? 1A, 2B, 3C. Then 4D, then 5F, and then 7. This is the path 1. Now, what is the path 2? Path 2. So, what should be the path 2? Same. The path 2 should be 1A, right? Same. 2B, like 2B, B. Then what next? 3C. 3C. So I am taking this path now. 3C. Then 4E. Then 4E. Right. Then what next? 6G. Then 6G. Right. Then what is the last? That is 7. Clear? So this is the path 2. 1A, 2B, 3C, 4E, 6G and 7. So we are getting only two paths here. So this is the one path and this is the another path. So how to calculate the path value here? Like that way. Okay. Now, so here, so now I am calculating one by one. First, we are calculating the branch coverage for taking that path 1 value. Clear? So first we are taking the path 1 value to calculate the branch coverage. Now I am taking the path 1 value. So this is the path 1. Now, so here, simple. So here we can see what is my formula. So this is my formula. Branch coverage equals to number of branches covered divided by total number of branches multiply 100. So number of branches covered, it means how many branch we have covered. How many branch we have covered? So A, so A is the branch A, B, C, D and F. First I am taking the path 1. So path 1 for the path 1 we are taking we was what we have taken this path. So as we have taken this path, so now what is the total covered branch? So the covered branches. What are the covered branches? So covered branches are A, A, then B, then C, then what next? C, then this is the D, right? Then what next? The F. So this is for path 1. So this is for path 1. Okay. So covered branches are A, B, C, D and F. Right. So first I am taking the path 1. So this is so as per the formula we are getting the number of branches covered. That means the number of branches covered is here 5. We are getting 5 here. 1, 2, 3, 4, 5. Okay. And what is the next? Next is the total number of branches. So how many branches are there? So total number of branches 1, 2, 3, 4, 5, 6 and 7. Total 7 branches are there. We can see that A, B, C. So this is the total branches. A, B, C, D, E, F, G. This is the total branches. So I am naming it as like branches. So branches. So this is the total branches. Total branches is 1, 2, 3, 4, 5, 6, 7. So this is the covered branches and this is the total branches. Now then what is the formula? Formula is that number of branches covered, that means number of branches 5 divide by what next? Total number of branches. So total number of branches here is 7. 4, 3, 7. So this is the 7, 7. So like that and multiply 100. So this is the branch coverage. So this is the B dot C. This is the branch coverage. So now I am opening my calculator here. So 5 divided by 7 is equals to this one 7.71 into 100. Multiply 100. So 71. So what is my branch coverage? So branch coverage for that path 1 is 70 equals to 71%. So branch coverage for the path 1 is 71%. Now I am taking the path 2 for calculating the branch coverage. So I am taking the path 2. So here what should be the covered branches? So covered branches. What is the covered branches? So covered branches are okay. Now I am taking for the path 2. We have taken this path. Okay. So now what are the covered branches? So covered branches are A, then what next? B. So B, then what next? Then C, then what next? E, and then what next? Then G, right? A, B, C, E and G. How much? Total 5. So total covered branches are 5. Okay. So this is for path 2. This is for path 2. So what is the formula says? Formula says that branch coverage equal to number of branches covered. So here number of branches covered is 5 also, and then divide by total number of branches. So total number of branches should always the same value. This is always the same. Okay, so this should be the same. Total branches, how many branches are there? Total 7 branch. So here the branch coverage is, so B dot C means branch coverage. Okay, so B dot C equal to same. What? What is the covered branches? That is 5. Then what is the total number of branches? That is 7, and multiply 100. So again it should be the 71%. So this is the branch coverage for the second path. So this is the total concept of branch coverage testing technique. Okay, so in your case there should be another, condition. So no problem, you can easily draw this, you can easily draw the flow structure like that, and you can easily calculate the path, how many paths are there. Maybe in your case there should be 3 paths, 4 paths. So depending upon your programming structure, the path should be different, and as per the path we can easily calculate the covered branches for each and every path, and then we can get the total branches. Then we can easily calculate the branch coverage for each of the path. Okay, so I think this will help you very, in your case also, in your interview purpose, in your testing knowledge. So I think you guys are understand the concept of the branch coverage testing technique. So this is the branch coverage testing technique. So we have to follow that branch coverage testing technique. So if you guys like my video, one thumbs up, share this video with your nearest friend, and subscribe to my channel EduPaat. So see you in the next videos with some another interesting topic of software testing. Thank you.